Today we will be talking about capacitors.
Capacitors are devices that hold charge. When a potential is introduced across the plates of a capacitor, electrons begin to accumulate on one side and push the electrons on the other side away. Since like charges repel, adding every additional charge requires more energy, and the capacitor increasingly resists the flow of charge. Eventually, the capacitor charges until its voltage equals that of the battery. The circuit has reached steady state. This is summarized by charge equals capacitance times voltage.
So, what are capacitors used for?
Due to their ability to discharge quickly, capacitors are used in cameras.
A camera flash, for example, requires a lot of charge, and fast.
This can be achieved by charging a capacitor and discharging it quickly.
Now let's look at the math behind discharging a capacitor.
We start with a capacitor of charge Q and a resistor of resistance R. Since, from the loop rule, the potential across the capacitor equals the voltage of the resistor, current is defined as the change in charge over the change in time. Now, let's rearrange the variables and solve the resulting differential equation. The bounds of integration are from 0 to variable time t and from Q0 to some charge Q. And thus we get exponential decay. Now let's build the capacitor. Pencil sharpened. Tin foil is a good capacitor plate. Paper is the perfect dielectric. Now let's roll it up for compactness. Current travels from the power supply through the resistor, through the capacitor, and reaches ground. Let's close the circuit to charge the capacitor. Now let's connect it across the resistor for discharge.
Thank you for listening.